go over sinusoidal functions today, and we're going to walk through the characteristics of a sine wave. So if you guys recall sine from our primary trig ratio, sine is equal to opposite over hypotenuse. This is a representation, okay, of these ratios. Now, we don't really have to know that. What we're really going to focus on is the major coordinates in a sine wave and how to graph one. Okay, and if we get very interested, we can go over all of these specific points. But what we're looking for here is there are 5 major points I would like you guys to know. So if I are asked to graph this function, f at x equals sine x, there's 5 major points. One of them is the origin. So this starts at the origin at 0 and 0. Okay. The next major coordinate I want you to know, and our x-axis is in degrees. Make sure we have that. Our next major coordinate is at 90 and 1. Okay? And just like when we were doing quadratics before, we have our major points, one at the origin, one at 1 and 1, 2 and 4. We're going over the same idea, how to graph the basis of a sine wave. The next major point is 180 and 0. And this is, remember, like our periodic function. It has that type of pattern to this. So we have 180 and 0. What does the next one say? Can anyone see it? This is 270. If anybody's into skateboarding, you might be used to these. And negative 1. Okay. And finally, our last one is at 360 and 0. These are 5 major coordinates you'll definitely need to know for your quiz coming up. And 450 is the repeating pattern. So what we've just completed here, going from the middle to our peak, down to a trough, and back to the middle again. Does anyone know what that cycle is called? We went through it yesterday with, what will we call this start? It starts with a P. Period, right? This is the period of the function. So the period of a sine wave is how long? How long is the period? 360, right? 360 degrees to be exact. So the idea here is like we're drawing a circle as we go through this, right? We're starting at our 0 point, and we go up to 90, so this would be up to 90 degrees, okay? Here's our 90 degrees. Then we continue back to 180, and 180, if you notice, we're back at the same level where we started. That's why it's 0 in terms of the difference. So we're at 180 degrees. Then from there, the next part of our circle, we go down to 270 degrees, and we're at negative 1. So we're below where we started by 1 degree. So imagine this radius of this circle is 1. So we're moving 1 all the way around. Okay? So we got to 90, then the 180, then we're down 1. And finally, we start back where we are, or where we were, at 360 degrees. Okay? And that's the complete period of a sine wave. It's like creating a circle. So there's some major coordinates we need to know in order to graph these. And we went over the points. We've now figured out a period. So the period of this wave is 360 degrees. Okay. What is a peak? Or what is the peak of this sine wave? Yeah, we have a peak, and it's continuously reoccurring. How often does the peak reoccur? How many degrees do we go through for the peak to reoccur? So one is from negative 270 back to 90. How far is this? Think about it. 360, right? If we started here on the circle to get back to here, how long does it take us? It takes us 360 degrees. So the peaks occur every 360 degrees, essentially the period of the function, right? What about our trough, or our lowest point? What is it? Yeah, our 270 is our trough. How often does that reoccur? That's right, every 360 degrees. It's the exact same pattern all the way through. How do we calculate the range of this function? Yeah, we subtract the peak from the trough. So our range is equal to the peak subtract the trough. So what is our value of our peak? Let's think about distances in terms of the y-axis, because this would be left to right, right? What about up and down? The range would be an up and down measurement. So what is it, Ivan?
1.
Yeah, our peak is 1, and what is our trough? -1. So our peak is the value of 1, and we subtract -1. How far is our range? 2. That makes sense, right? We're going from 1 all the way down to -1. That's a difference of 2. So the range of this function is technically 2 units. Now, there's something called an amplitude of this function. And the amplitude deals with going from the middle to a peak or a trough. It should be the exact same distance. Okay? So, in order to find the amplitude of a function, the amplitude is very similar to our range. In fact, we take the range and we divide by 2. Okay? So, our amplitude is, and they usually write it as the max subtract the min, which are the exact same idea as our peak subtract our trough. The only difference is we divide it by 2. So what is our max subtract our min? We already calculated it.
1.
Just the max subtract min, not divided by 2. So what was our range? 2. Okay? And we still have to divide it by 2. So what is the amplitude of this function? 1, that's right. So going from the middle of this wave, the distance to the highest point is 1 unit, which is the exact same as the distance to the lowest point, which is 1 unit. This is called the amplitude of a function. Okay? So from here to here, or here to here, both known as the amplitude. Along with that, we want to measure where the middle of the wave is. And this is called the equation of the axis. Okay? This is known as the equation the axis is kind of like thinking of a wheel, a circle. The axle of the wheel falls right in the middle. So we want to know where the middle of this circle is. So we need to be able to calculate that. And we calculate that using the same idea with our max and our min, or our peak and our trough. We'll call it max and min. I'm going to call this the EOA. EOA. Equation of axis. And we take our max, but instead of subtracting, we add the minimum. And then we divide by a value of 2. So what was our max? Okay. Plus, what was our min? -1. What is -1 plus 1? 0 divided by 2 is 0. So the equation of the axis is when y is equal to 0, which is perfectly right in our case, because the equation of the axis is, let's see if I can get red here, is our x-axis. It falls right in the middle. And the equation of the axis is what we measure our amplitude from. Okay? So maybe it would have been more beneficial if we'd found that first, but the equation of the axis is where we measure to find out the distance of our amplitude. And all of these equations will help us find that information. Let's see. The life. Okay, so using the same example we have here, let's imagine that this sine wave is representing maybe a wheel. Okay, have you guys ever seen those water wheels that go into a river and bring water up? They're used to power. They used to be used to power way back in the day. Okay, so imagine we're at one part of the wheel. It comes to the top of its wheel, comes down. This is our water level. Goes under the water, comes back up to the surface, and back to where we started. So let's figure out a bit of information about this wheel. First of all, how high above the water is the highest point of this wheel? Is it 90? 1. Okay, we'll say it's measured in meters, our y-axis. Okay, so we'll say this is at 90 degrees. It is 1 meter above the water. At 180 degrees, how far above the water is it?
0.
Yeah, it's 0. At 270 degrees, so what does that mean? It's underwater. So it's now below water by 1 degree, so it's at -1. And at 360, what's it doing? Yeah, it's coming back out, right? It's coming out of the water. What is the diameter of this wheel?
1 meter.
2. And what is that the same as? The range. The range of the function, if we're talking about a wheel, is equal to the diameter of the circle. It's the distance through the middle of the circle to the other end of the circle. So our range is the exact same as the diameter. What about the radius? What would the radius of this wheel be? 1. And what is that the same as? Our amplitude, right? Our amplitude is the exact same as the radius of this wheel. So those two things help us equate to where it is. And where would the axle of the wheel be located?
0.
0. What does that mean? 0 in reference to what? The water. So it's pretty much on the surface of the water, the axle of the wheel. And the axle of the wheel is the same as the equation of the axis. The equation of the axis tells us where the axle of a wheel is.